Hello students, welcome to the next lecture on the PY questions. Today I will explain you based on your request is on countability. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of CSIR NET, and you can see the last lecture was on the eigenvalue matrix system, rank, all are available in this playlist. You can subscribe my YouTube channel so that you can get the notification when I uploaded my next video. Now today I will explain you how you can think about the problems related to the countability. The first very easiest way to solve the problem is whenever a question is related to the countability or uncountable, you always think about the cardinality. That means if you have the function from f a to b, then you can find the cardinality of a, cardinality of b. Now before I can directly jump into the PY question, let me quickly give you the certain tips. Based on that, you can solve each problem with the help of the 10 to 15 second time period. Make sure you have to subscribe my YouTube channel for the easiest notification. Now, whenever we are talking about the concept of the countability, the first things that come in our mind is the function is 1, 1 or the function is on 2. So how you can check the function is 1, 1 or on 2? So let's say first very simple tips for you. If you have the function from a to b, then the cardinality of the a is my n, cardinality of b is my m. Then how many functions map, like if this is my domain a, this is my domain b, and the function f is defined from a to b. How many 1, 1 function from a to b, how many on2 functions, and how many total functions defined from a to b, which I define this manner. The number of the maps from f from a to b is defined as cardinality of the b divided power cardinality of a. That means you can say the cardinality of b is my m raised to power n is the required answer of this problem. How many number of the 1, 1 maps? So 1, 1 map is m p n, that is the p is my permutation, m is the cardinality of the m, that is a range, and then codomain. How you can define the number of the onto maps? So first condition is m should be lies in between n. If m is lies between 1 to n, then you can define the number of the onto functions. Otherwise the number of the onto functions are my 0. And if it lies in between them, you can define the onto function is a summation part like this. Now this is a very important tips. If f and g are the two mappings such that the composition is my identity, this is my identity, then always the first function f is my 1, 1 and this g is my onto. These are very useful tips I will use many times in this video. Another is how you can check about the bijective. If you have a function f is a to b, then you can say f is bijective if and only if you can say the cardinality of a is cardinality of b. If f is 1, 1, then you can say the cardinality of a is less than or equal to the cardinality of b. But make sure the converse need not be true. That means if this condition hold, we can never say that f is 1, 1. Similarly, f is onto, then you can say the cardinality of a is greater than equal to cardinality of b. Make sure the converse is not true, but make sure that also you can see if this is not less than of this, what does it mean? What is the opposite of this? F is not 1, 1. Fine. Similarly for this on. How you can check about the equivalent? You can say the two sets are equivalent if there exists a 1, 1 and onto mapping from a to b. How you can check about the 1, 1 and onto? That is based on my this shortcut tips. If you have defined the two map, for example, if I taken the set of the natural numbers, set of the even numbers, then clearly say you can define the mapping from n to even number. So clearly say this 2n is my 1, 1 function and this is also onto. Hence n and e are my equivalents. How you can check about the countability? Infinite. If you prove that the set A is equivalent to the n, that means you can define the mapping from f a to n such that this is 1, 1 and on 2. That means if f is 1 1 and on 2, that means you have to prove that this is my bijective map. A is said to be the countable. How you can prove any of the set is countable? If you prove that set is either finite or it is my equivalent to the natural number. A set which is not countable, then you can say it is uncountable. A very simple examples, always remember the set of the integers, natural numbers, q, phi, n cross and all are my countables, while the irrational numbers and the r is my uncountable. And the cardinality of this natural number is alpha naught is the q and r is my c. Since r is my uncountable, so this c is my uncountable, these two are my countable. Very simple is every subset of the countable set is countable, every superset of the uncountable set is uncountable. If A and B are the countable, then you can say the intersection and the cross product is also countable. Every finite set is my countable and the countable union of the finite set is countable. And the last two comments is countable union of the countable set is countable, and if F is the mapping which is my onto and A is my countable, then B is my also countable. Now based on this simple shortcut tricks, I can solve all those PY questions, which is 40 plus PY question I have explained in this video. I hope you can like and comment on this video. If you are new to my YouTube video, you can scan and join my WhatsApp group. Let's start with the first PY question. What is given to you? X is the connected subset of the real number. What is the nature of this X? This is my connected. Fine. Now always remember, if you have a real number, always remember, if it is only for the real, X is a subset of the real number and satisfy the connected, then this X is of the two natures. Either this is my singleton, fine, or it is my interval. Only you have the two properties. If X is my connected and is a subset of the real number. Now look at that. If every element of the X is irrational, what is the meaning? Can it be lies in this interval? No, because for example, if I say 1 and 2, if every element of the X is irrational lies, but 1.5 is a real number, this is not irrational, that means this is not an interval. So what is the only X? X will be my singleton. So whatever the singleton set, the cardinality of this set is my 1. So the right answer of this problem is 1 is the right answer. X is a metric space such that A is the subset of the X and A is my connected. It is given to you. X is my metric space and we all know R is also the metric space. So I can consider X is my R. Fine. Then this A has again the two properties. First one, it is either the singleton or this is my interval. So once this is my singleton, but he said at least two distinct points. That means A has at least two distinct points. So it means it is not singleton. That means it is my interval. So once this is the interval, what does it mean? What is the cardinality of this case? It is my uncountable. So cardinality is uncountable. These three options are cancelled. Let P of X is alpha x square, beta x and gamma is a polynomial where alpha, beta, gamma are my real numbers. So I can choose alpha is 1, beta is 0, gamma is 0 because answer is not dependent on the alpha. So what is my Px? Px will be my x square. Then fix x naught belongs to the R. I can choose x naught is my 0. Fine. Such that the set S, which is defined as A, B, C, such that P of X is, if I take x naught is my 0, A, B and C. So A x square plus Bx plus C. Now I can substitute the Px. Px is my x square, which is equal to Ax square plus Bx plus C. So can you find the value of the A, B and C? So clearly say A is my 1, B is equal to 0, C is equal to 0. So what is my set S? Set S is my singleton. Fine. So that means A, B, C are my unique number. So what is the meaning of that? Is infinite cancel out, because the number of the elements in the set is 1. So 1 is the right answer. Rest options are cancelled. I hope you can like and comment on this video to spot it. If you want, I can upload my next video again on the real analysis or the complex analysis. But depending upon that, if I get a good response from this video, I will definitely upload my next video very soon. If f is my differentiable function such that f and f dash has no common 0, but it's very simple. You can simply choose x is 1 minus x square, f dash will be minus 2x. So clearly say what are the zeros of this. What are the roots of this is plus minus 1. What are the roots of this? Roots of this is my 0. There is no common root. This condition satisfied. Now look at the option. F never vanish on the 0, 1. Clearly say f of 1 is my 0. But he said never. This option cancel. F has at most finitely many zeros in closed interval 0, 1. Yes. How many zeros are there? Plus minus 1. That's a finite. At most finite. Fine. But these are one counter example. We can't correct this example, this option based on this counter example. F has infinitely many zeros in the 0, 1. That's wrong, because it has only finite zeros. But the option suggests infinite many zeros. F of half is my 0. You can see what is the f of half? 3 by 4, which is non-zero. So all the options are cancelled out. Right option is my B is my right answer. You can see a very simple example you can put up, and then you can solve this in a very simple way. You may think about any of the other example as well. Fine, this is the one of the example. I hope you can like and comment on this video to spot it. Now, uncountable. Which of the following is uncountable? Always remember, whenever you are thinking about the uncountable, always remember R is my uncountable. Fine. Z, empty set, Q, all are my countable. Fine. Now look at that. First option. Collection of all those x. So our target is to check about the nature of these x. Log of x is p by q. Now p and q is in my natural number. We have to define p over q. P over q is belongs to the q. Now what is the q? Q is my countable. So once q is my countable, that means x is also my countable. But we need a uncountable. First option is cancel. N is my natural number. So if you, for some natural number, say let's say n is my 2, then this number will be cos square x plus sin square x is 1. This is 2 for all x is in R. And what is the R? R is my uncountable. So this option is the correct option. P and Q belongs to the natural number. What is the P over Q? P over Q is again in the Q, and Q is my countable. So this is my countable. P and Q is in my N. This P over Q is belongs to the Q, and Q is my countable. So therefore X is also countable. But this option is also cancelled. Right option is the B is my right answer. Now this time we are thinking about the countable. The set of the function from Q to Q is countable or not. Fine. So you can define the number of the maps. How you can define the number of the maps? How you can define the mapping from A to B? Cardinality of B divided by cardinality of A. So that means cardinality of Q raised to power cardinality of Q. Cardinality of Q is F0. What is this? Fine. So that means this is my C, and C is my uncountable. But we need a countable. So this option is cancelled. Second option is F is a mapping from Q to 0, 1. How many maps are there? So cardinality of this is my 2. Cardinality of this is my F0. So 2 raised to power F0. This is my again C, which is uncountable. This option is also cancelled out. Next one is F is the mapping again from the Q to 0, 1, which vanish outside the finite set. Fine. Okay, we will think about the fourth option firstly. Set of all those subset of the n, that is my power set. Fine. What is the cardinality of the power set? 2 raised to power n. So it's a 2 raised to power alpha naught, that is again c, which is my uncountable. So which is uncountable, but we need a countable. So this option is cancelled. Only left option is my C is the right answer of this problem. But how you can prove that? Which vanish set of all those functions which vanish outside the finite set. I can define the set which vanish. I can define the function say 1 and outside that is my 0. Fine. Now A, where A is my finite set. Clear? Then you can say the function of all those. What is that? You can write as a union. Now f of A is my finite set and countable. Union of the countable set is countable. So therefore the third option is the correct option. Which of the following set is my countable? The set of all those polynomials with the rational. What is the degree of polynomial? Not given. So I can say the degree of polynomial is linear. A plus bx. What is my A and B? Are the rational coefficients. Fine. Now once they are the rational coefficient, what is the Q? Q is my, sorry, it's a rational coefficient. Yes. So once they are the rational coefficients, how you can define that? Which of the following is my countable? A and B is Q. Q is my countable. So that means F is my countable. Set of all those polynomials with the real coefficients. F is again A plus bx, where A and B is in my real coefficients. So once it's a real coefficients, they are my uncountable. Fine. And roots are my rational. So whatever what's the root of this one is minus A over B, which belongs to the Q. Fine. Or you can define as function is x minus say 5, so where A is my R and R is my uncountable. So this is my uncountable. Set of all those 2 cross 2 real matrix with the rational eigenvalues. I can choose the rational eigenvalues 1 over 2, 1 over 4. I called 0. Then the eigenvalues are rational, but A is in my any real number and R is my uncountable. So that means this matrix is my uncountable. So but we need a countable. Set of all those real matrix whose row echelon form has rational entries. Okay, fine. So firstly you can think about the matrix. Any matrix I can choose again as a 2 cross 2 matrix, say A, B, 1, 1. Fine. So if you convert into the row echelon form, that means the first number must be 1. This number can be anything. So say B over A. Fine. Or you can say this number can be anything. Fine. Once you operate them, it will be my 1. Now clearly say this A and B is in my R. So what does it mean? This matrix A and B is in my R. R is my uncountable. So the corresponding matrix, the set corresponding to this matrix is also my uncountable, but we need a countable. So the right answer is only A is my right answer. Which of the following subset of the R2 is uncountable? Again, what is given to you? A comma B belongs to the R2. A is less than equal to B. From where A and B is in R. R is my uncountable. So this is my uncountable. A plus B, it belongs to the Q. This is the condition. But from where A and B came, A is R and it is my uncountable. So yes, this is uncountable. AB belongs to the Z. Fine. So what is the condition for the A and B? A and B is the part of the R, which is the uncountable. A and B now is a comma B, which are in the Q. Q is my countable, but this is my countable. So the right answers are A, B and C are the correct options. Kindly don't forget to like and comment on this video to support it. I will upload very soon the next video based on your likes and comments. Which of the following functions are my uncountable? Now once the function, we have to think about the cardinality. Fine. Now what is the cardinality of this function? Cardinality of this is my 2 raised to power cardinality of this n. 2 raised to power, this is my C, and C is my uncountable, and we need a uncountable. Second option is, what is the cardinality of this? Second cardinality is alpha naught raised to power cardinality of 1, 2 is chi-square, that is a alpha naught, which is countable. So this is option is cancelled out. What is the cardinality of this? Chi naught raised to power 2, which is again my this number, which is again countable. There is no significance of this case because it's a mapping from 1 and 2. That's a monotonic. So this is my countable. What is the cardinality of this? 2 raised to power chi naught, that is C, which is my uncountable. So yes, this is also the right answer. So A and D are my correct answer of this problem. Which of the following sets are my uncountable? Which of the following sets are my uncountable? Set of all those functions. Now again they are talking about the function. So what you can do, you have to take about the cardinality. So that means a function from R to 0, 1. What is the cardinality of this? 2 raised to power C. 2 raised to power C is always greater than C. Fine. So that means this is my, and this is my uncountable. Superset of the uncountable set is uncountable. So the first option is my uncountable right answer. This is the mapping from n to 0, 1. What is the cardinality of this? 2. What is the cardinality of this? Alpha naught, that's a C, which is again uncountable. That's also correct option. The set of all the finite subset of the n. What is the finite subset of the n is? Power set. Okay, finite subset. Okay, n is my countable. No, it's not. It's a countable finite subset. So I called A. N is my countable. Finite subset of the countable set is countable. So I need uncountable. Set of all those, all subset of the n. Set of all subset of the n is my power set. Fine. So what is the cardinality of the power set? 2 raised to power cardinality of the n. Cardinality of the n is alpha naught, that is C. C is my uncountable. So that means the right options are A, B and D are my right answer of this problem. S is my infinite set. S is my infinite set. So can you think about any of the infinite set? R, any other infinite set? Q or N, anything are there? Which of the following statement are true? If there is a injective map from S to N, that is a 1, 1. If there is a 1, 1 map, then S is countable. Now it means this is existence. What is the property? As I told you, that means the cardinality of S must be less than of the cardinality of the N. Fine. That's the property of the 1, 1 as I told you in the starting. So what is the N? This is my, this number. Fine. Now what is the S? If I choose S is my R, what is the cardinality of the S? C. So that means this, what is the, there is, then S is a countable. So that's definitely S cardinal, no, S, then there exists, okay, this I have proof from this. This is my countable. Fine. Subset of the countable set is countable. So yes, S is my countable. If there exists a onto map, then what is the property of the onto map? This number should be greater than of this number. Fine. this is my countable. So it may or may not be true. Why? It may be the countable or it may be the uncountable, because remember, subset of the countable set is countable, superset of uncountable set is uncountable. So that means it's a countable, so it's a countable or uncountable. So that is not always true. If there is a 1-1 map from N to S, it's a 1-1, then S is countable. That means this condition hold. Fine. N is the subset of this. Now cardinality of this N is alpha naught. Again you can see that this is the same case. Cardinality of S is greater than or equal to cardinality of N. So that means this again S is either the countable or not. If there is a onto map from N to S, that means cardinality of N is greater than or equal to cardinality of the S, then S is countable. How you can write that? That means fine, this is my countable, so that means this is also my countable. So yes, A and D are my correct option of this example. Which of the following set is my bijective with R? Which of the following set is bijective? What is the cardinality of R is? C. So we can see, because it's a bijective, F is the mapping from A to B is bijective when cardinality of A is cardinality of B. So now which of the following set is bijective with R? So I will check which one of them cardinality. C. Look at the first part. A map from 0,1 to N. Can you find the cardinality? Cardinality of N is alpha naught. Cardinality of this is 2, which is, it is not C. So it is not bijective. This one, it is 2. Cardinality of this is 2. Cardinality of this is alpha naught, which is my C. Yes, this is my bijective map. Set of all subset of N. Set of all subset of N, that is a power set. So cardinality of this power set is 2 raised to power cardinality of the N, which is again C. Yes, this is a bijection. Subset of all those R, that is a power set of the R. So what is the cardinality of the power set of R is 2 raised to power C, which is greater than of C. That means it is not bijective with R. Right answers are B and C are the right answer. Always remember, whenever you have to think about the set, function, cardinality or countability, always think about the cardinality. Let N is the set of the natural numbers. Which of the following function from N cross N to N is my 1, 1. Now make sure, as I told you, if F is my 1, 1, then cardinality of A is less than of the cardinality of B, but converse is not true. In this case 1, 1 is not given to you. Fine. So how you can check about the 1, 1? That means if I take x1 y1 as x2 y2, then your target is to prove that both the points are my same. Fine. Now you can easily eliminate that. Clearly say this function is my symmetric. Is it symmetric? Yes. So clearly say if you fix them any one point, 1 comma anything, then definitely you can choose any point, it will be same. Fine. For example, I can choose 1 comma 2. What is the value of the 1 comma 2? 2 plus 1 plus 2, that is 5. What is the point of the f of 2 comma 1? Because it's a symmetric function, so both are same, but 1 comma 2 is not equal to 2 comma 1. It is not 1. That means symmetric function is not a 1, 1. Look at the third option. Again you can see m square plus n cube. I can fix the one number 1. Fine. And any number I can choose, like 1 plus n cube. Fine. Then other number is I can fix n is my 1, it is my m square. Now can you think about the value of 1, m and n so that this will be equal? So clearly say if I choose n is my 2, then it is my 8. Can you choose any of the m from the n so that it will be 8? No. If I choose n is my 3, it is my 27? No. If I choose n is my 4, then it's a 64? Yes. I can choose 8, 64 plus 1. I can choose 4, 1 plus 64. We can see both the numbers are same, but they are not equal. Look at this fourth again. Again fourth is the product of them. Again I can choose 1 is my 1 and another number is 1. So what will happen? It is my n cube, it is my m square. Can you choose any of the n? Again you can choose 4, 8. Both the numbers are my 64, 64, but they are not equal. So that means these three options are cancelled out. This function is my only 1, 1 is the right answer. Let x comma y be defined as collection of all those sequence. This is my sequence. Remember, sequence is the mapping from n to r. xn is the sequence which are defined from n to where xn is the mapping such that limit of the supremum is my 1. It's a limit of the supremum. Fine. The value is my 1. Okay, y is a mapping, again is a sequence, limit does not exist. Fine. Can you find the cardinality of this x? Because they are talking about the countable, we always think about the cardinality. What is the cardinality of y? C. C is my uncountable. What is the cardinality of this? Again C, it is uncountable. So both are my uncountable is the right answer of this problem. What is the meaning of this limit supremum 1? That means the values are either 0, 1 and at some point it is approaches as a 1, 1. Similarly, limit does not exist means the limits are either 0, 1 or anything. Let S is my infinite set. Again, either your infinite set is R or infinite set is your Q. Fine. Assuming the axiom of choice, which of the following is my true? S is the bisection. If I define as a mapping, S is the bisection with the Q. When it will be the bisection, bijective map? When the cardinality of S is my cardinality of Q. Fine. This is your target. Is it true? No. If I choose S is my R, fine, then cardinality of Q will be my alpha naught, cardinality of R will be my C, which are not same. That means it is not bijective. Look at the second. S mapping is bijective with the R. Is it true? What is the cardinality of this side is C. If I choose S is my Q, because Q is S is my infinite, I can choose this time as a Q. So if S is Q, what is the cardinality of this? Again you can see they are not same. It is not a bijective. Third option is S is the bijective with the S cross S. If you define the map from this number, then then this will be. How you can what is the cardinality of this? How you can define the cardinal? Okay, how you can define the cardinality of this? Okay, firstly I can think about the fourth option. Otherwise we know there are two cases. If I choose S is Q firstly, fine, then the cardinality of the S cross X will be this number, which is my fine, and the cardinality of this is again same. So that means yes, this is the bijective. But the second case is if I choose S is my R, then it's mapping from basically R to R cross R. What is the bijective? What is the cardinality of this? C. Cardinality of this is also C. Yes, in both the cases it is my bijective. Look at the last case. If S is the mapping bijective with the power set. So S to the power set. What is the cardinality of the power set? Say S is my Q. Fine. What is the cardinality of this power set? It will be 2 raised to power cardinality of, so it is my C, and S is my Q. So cardinality of this S is alpha naught. Both are not equal, so they are not bijective. So therefore right answer is C is the correct answer of this problem. Make sure students, whenever there is a question related to the bijective 1 1 on to, always think about the cardinality. I hope you enjoyed this session. I will see if you like and comment on my this video for the sport then. Which of the following statement is or are true? There exists a continuous map, there exists a continuous map, continuous map, continuous map. Always remember student. Now in this question you can see they are not asking you about the cardinality, they are not asking you about the bisection 1 1 or anything are there. Okay, they are not talking about the bijective map. Always remember, whenever you have a mapping from A to B and question is related to the continuous, fine, whether the continuous map exists or not, always remember, we all know if it is a continuous map, then f of open will be open, fine, f of compact set will map on the compact set, f of connected set will map on the connected set, fine, f of the closed set under a continuous mapping is map on the closed set, and so on. F of the discontinuous set, disconnected set will map on the disconnected set. Now look at this option. We will see the option by using this manner. F is the mapping from R to R such that f of R is my Q. So can you think about, there is a continuous map which map this R, f of R to the Q or not? You can see R is my connected, fine. What is the Q? Q is my not connected. So what is the meaning of that? But f is my continuous. If f is a continuous, then it map connected set to the connected set. It means f is my discontinuous. So therefore there exists no. Again R is my connected, but Z is again my not connected, fine. So it means there does not exist any continuous map. Look at the third option. F is the mapping from R to R square such that f of R will map on the unit circle, boundary of the unit circle, fine. That means if you have taken any point on this case, it will map on this only on the boundary because the equality appears. Is it possible? Yes, you can choose any point x on the real line. Can you write any point on this circle? It is cos x, sin x. Yes, fine. So x map to the cos x and sin x such that cos square plus sin square is my 1. Clearly say cos square x plus sin square is my 1. Satisfied? Yes, it is my possible. There exists a continuous map f on the closed interval 0, 1 union 2, 3. First of all 0, 1 this one, 2, 3 this one. That means this is my disconnected set. You are unable to move from 0, 1 to 2, 3 directly. What is a 0, it's a set. So either the 0 only or 1 only. So clearly say this is also my disconnected set, fine. So there is a map which map discontinuity to they map disconnected to the disconnected, and that map will be my continuous. Yes, this option is also corrected. C and D are my corrected. Which of the following set is my countable? Again the countable. So we will think about the cardinality. Set of all those, again the polynomial is not given. I can say the polynomial degree is my 1. So f is a plus bx such that real coefficients, that means a and b belongs to the R. What is the R? R is my uncountable. So that means F is my uncountable, but we need a countable. Set of all those polynomials with the rational coefficients a plus bx such that a and b is in my Q. Q is my countable. Corresponding the function is also my countable. Yes, this is the right answer. Set of all those polynomials with the real coefficients and rational roots. So a times x minus any real number, say 5, again fine. What is the root of this? Root is my 5, which is also the part of the Q, fine. Or if I say ax minus b or ax plus b, what is my root is minus b over a, and a and b are my real coefficients. So then b over a is in my Q, but a and b is in my R, and R is my uncountable. So yes, this is also my uncountable. Look at this, another one. Set of all 2 cross 2 matrix with the rational coefficient. So rational coefficient, I can say, no, I need a countable, but this is uncountable. This option is wrong. I can choose 1 over 3. These are the eigenvalues. Fine. Eigenvalues are my rational numbers. But what is the A? A can be any R, but R is my uncountable. So this means this matrix is also my uncountable, but we need a countable. This option is cancelled. Only B option is the right answer of the problem. Consider the set of the sequence X, and again you are talking about the countability. That means we are talking about the cardinality. You can define the X and Y. What is the X is? It's a sequence. So sequence defined from the natural number to xn belongs to the 0, 1. Fine. Y, natural number to xn is my only 1. Fine. At most finite. So can you define the cardinality of the X? Cardinality of 0, 1 is 2. Cardinality of the n is, so this is my C. So C is my uncountable. That means X is my uncountable. X is countable. X is countable. Cancel. Y. What is the cardinality of Y? It's a singleton set. Cardinality is 1. So that is my 1. It's a finite. And every finite set is my countable. So that means Y is my countable. B is the correct option. This option is, because remember, every finite set is my countable. Every finite set is countable. So therefore, right answer is B is my correct option. Don't forget to like and comment on my video. I will upload the next video based on your good response related to this comments and the like side. Which of the following statement is true? There are at most continuous map, continuous subject onto map, subjective map, maps. That means again F from A to B is my continuous. Fine. So that means we have to think about F open to open, close to close, and so on. But simultaneously we are talking about the countability. That means we are thinking about the cardinality. Fine. We are thinking about the cardinality because onto is also related to cardinality, injective also cardinality, bijective also. So look at the first option. F is a mapping from R2 to R. Second option again R2 to R, and so on. Okay. What is the cardinality of R? What is the cardinality of the R is C. Fine. What is the cardinality of R2? C raised to power C is R cross R. Fine. So but is it not equal to C? That means cardinality of R is not equal to the cardinality of R2. That means if both cardinalities are not there, it means there is no bijective map. Fine. So if there is no bijective map okay, now countability or this, how many maps are there? Cardinality of r raised to power cardinality of r square, so c raised to power c square. Clear? Now c and c square, which is not finite. Fine. Or you can say which is not countable, is uncountable. Now look at the option. The first option said is a countable. At most finite, but it is not a finite. Cancel out. Infinitely many continuous injective map. Infinitely many continuous inject, but it is not a finite. It is not a countable. There is no continuous bijective map. Yes, there is no bijective map is the right answer of this problem. Why I consider as a cardinality? Because if it is only the continuous map, then we can think about in this manner. Continuous map will connected to connected, compact to compact, close to the close, disconnected to disconnected. Look at that. In this question, they are not talking about the 1-1 countable onto bijective. It is nothing is given to you. But in this question, they are talking about the subjective onto and so on. That's why I am thinking about the cardinality. Which of the following case there is no continuous function f? Again, you can see a to b talking about the continuous. Are they talking about the 1-1 onto countability? No. So again, I will use the same concept. If it is a continuous, f open map will be the open, compact map to the compact, complete compact to the complete, and so on. So now we need a there is no. Fine. It means we need to find the discontinuous function. Very simple. Look at that. Firstly, f is the mapping from S to T. If I look about the D, R is my open map. Fine. This is also open. So definitely there exists a function f from R to 0, 1, which map open to open. So that means this f is my continuous, but we need a no continuous. This option is cancelled. This is the open. This is the open. Cancel out. This is the open. This is the open. Cancel out. The only left option is my A is the correct answer. But you think how? Clearly say this is my not. What is that? Is it connected? This is not compact, but it's a closed and bounded, so it is my compact. Fine. So it means compact to the non-compact only possible when you have the discontinuous function. So the right answer is A is my right answer. Okay, it's a recent December 2023. Let X is the non-empty finite set. I can assume the non-empty finite set cardinality is say 1. Fine. So that means if I choose the X which has only one element, you may choose the cardinality as a 2, but that must be finite. Fine. But the easiest way I can choose in this manner. Y is a f inverse 0, where f is a real value. Fine. F is a real value function from this to this. Fine. It can be any real value function. It may be f of x is sin x, it may be e raised to power x, or anything. Now they are talking about the infinite set, bijective map, subjective map. That means again we can think about the cardinality. Fine. Now how many elements in this y? It may be more than 1. Fine. But f inverse 0, so definitely one element must be 0. Clear? Now f inverse 0, so you have to define the mapping f inverse 0 this side. What is the image of f? So what is the f inverse 0? Look at that. There are the two possibilities. First possibility is that that element will map to this. Then what is the f inverse 0 is? If I quote this element is my x, then that element will be X. On the other hand, if this element will map on this case, fine, then what is the F inverse 0? F0 will be phi. So you have the only two possibilities, that whether f of x is 0 or f of x is, say this number is, say my y, or non-zero. Fine. So then what is my f inverse 0? F inverse 0 is either that element x or is a phi. So what is the cardinality of this set? So this is my y. So what is the cardinality of this y is 2. Fine. Now look at the option. Y is infinite set. Wrong, because this is my finite set. So first option is cancelled. What is the cardinality of x is 1. So this has the cardinality 2. Yes. There is a bijective map from x to y. What is the condition for the bijective? Cardinality of y must be cardinality of x. But you can see cardinality of x is 1, cardinality of y is 2. So there is no bijective map between them. There is a subjective map. As I told you, when it will be the onto, when the cardinality of x must be greater than or equal to the cardinality of y, then only it's onto. If it is onto, then this condition hold. But you can see cardinality of x is not greater than of the cardinality of y, because 1 is not greater than 2. That means it is my not onto. So that means this is subjective map. Wrong option. B option is the right answer. And you can see within the fraction of second you can solve this problem very simple manner. As you know that I already explained you in many of the video, you can choose, once is a finite, you can choose the value as per your convenience. Okay, let z denotes the set of the integers, and z greater than equal to 0 is the values which contains the 0 as well. Fine. That's only the positive numbers. Fine. Consider the map f from z greater than 0 cross z to this such that f 2 raised to power m into 2 raised to power n plus 1 is 1 1 on 2 and so on. Always remember again, if f from a to b is 1 1, then cardinality of a is less than equal to cardinality of b, but converse not true. Fine. Converse is not true. Now you can't use this concept because f is 1 1 is not given to you. Your target is to prove this one. Fine. But if you prove that the cardinality of a is greater than equal to cardinality of b, then you can say it is not. Converse is true only for the not case. So now clearly say, if you look about this problem very carefully, it is similar to the previous one. You can see in the previous one is this one. Fine. If you look about that, this is my even function, this is odd and even both. You can see what is this kind. This is my even, this is odd. Fine. M belongs to this part, n is my set of integers. Now look at that. Can this 2n plus 1 will be 0 for any case? It can never be 0 because 2n plus 1 is always odd. Fine. Can this number will be the 0? This number can never be 0 because m is my positive. Fine. That means f of m comma m is can never be 0. What does it mean? That means there does not exist any m or n such that f inverse of 0 you can define. But you can see the right hand side is z, which involvement of the 0. What does it mean? You have the no pre-image. So once it's a no pre-image, that means whether the function is onto or not, the function is not onto. Fine. So whether it's onto, wrong, not onto, both 1 1, neither onto. Fine. That's a simple one, because you can never find a pair of m comma n from this case whose image will be my 0, because this part can never be 0. Now How you can check about the 1 1? Again, a very simple, I can start from the 2 pairs. Fine. That means I can start from the M1 N1 and M2 N2. So what is that number? 2 M1, 2 N1 plus 1, 2 M2, 2 N2 plus 1. Now when the product will be equal, this is the even component. Even component must be equal to the even, odd must be equal to the odd. Fine. That means 2 M1 is equal to 2 M2. That means M1 is equal to M2, and from this case we can obtain N1 is equal to N2. Therefore it is my 1 1. So it's a 1 1. Neither the 1 1, wrong. B is the right answer of this problem. Okay, which of the following statement is necessarily true for this case? Okay, first part, f is 1 1. Then there exists a function such that f g circle y is equal to y. What does it means? F circle g is my identity. Fine. Now remember my earlier shortcut tricks. When it will be the identity, then this part will be my 1 1, this value will be my onto. But you can see he said f is my 1 1, but we need a f is onto, so that means there does not exist any g. Look at the second part, f is given to be my onto, then this is given. Fine, this is given to you. This is given to you. If this is given to you, that means cardinality of x is greater than of the cardinality of y. F is 1 1 means cardinality of x is less than of the cardinality of y. Again you can see this is the identity map. F circle g is my identity. So I need this g is my 1 1. This outside f will be my onto. Yes, you can see f is my onto. What does it mean? There exists a g which is my 1 1. Fine. You can define any of the g. G of x will be my x. It's a 1 1 function. So yes, it is my true statement. Now look at this third option. F is given to you, again 1 1. That means cardinality of x is less than equal to cardinality of y, and y is my countable. It is given to you that y is my countable. Then x is finite. Remember, every finite set is countable. Fine. Now cardinality of y is less than of the cardinality of x. Y is my countable, but that x countable, subset of the countable set is countable. Fine. Every finite set is countable, so that means this x is either the finite or this set is either the countable. But he said x is my finite. That is not always true. It may be the countable, so that option is cancelled. Look at this last option. F is subjective. Again it is given to you. Then what is the meaning of that? Cardinality of x is greater than equal to cardinality of y. X is my countable. I can write this number is this manner. Fine. So it means this time this is given to you as a uncountable. What is the property of that? Superset of the uncountable set is uncountable set. Fine. Then y is my countably infinite. Y is my countably infinite. If x is my uncountable, what can you say about the y? Y can be finite because cardinality of y is less than of the x. So it is uncountable. Fine. So y may be a finite or may be a uncountable. So that means is what he said, countably infinite. So you can say either countably infinite or a finite. So that means this option is also cancelled out. Right options are only my B is the right answer. Okay, consider the two set A and B. Which of the following statement is the correct? F is the mapping from A to B. The total number of the functions how many functions are there? Cardinality of B divided power cardinality of A. So can you define the cardinality of A? 3. Cardinality of B is 5. So that means 5 raised to power 3, 125. Correct option. Total number of the functions from A to B, again it's a 125, but he said 243. Total number of the 1 to 1. So if F is a mapping from A to B, how many 1 1 mappings are there? Cardinality of M, cardinality of B, permutation, cardinality of N. A is my say N. So what is the cardinality of B? 5, permutation C. So that means 5 factorial over 5 minus 3 factorial. So 120 divided by 2, 60 is the right answer. 120 is the wrong answer. So A and C are the correct answer of this problem. Okay, let A and B are the two sets which are the following statement is my true. There is a 1 1 on 2, 1 1 on 2, 1 1 on 2. Now you can see you are unable to define the cardinality. I can draw the graph x from 0 to 1. This is a mapping from the 0 to 1. X cube. X cube is defined like this way, but I need a from 1 to 2. So it is, what is the graph of the x cube? This is the graph of the x cube. Now I need a value from, this is the graph of the x cube. Fine. Now how you can check about the whether it's a 1 1 on 2 map? That's a bijective map. You all know. You can see now once you can draw the graphically, you can put your answer in the graphically. How you can check about the 1 1? Draw the horizontal line in the graph. If it cut only the 1 point, if it cut only the 1 point, then it is a 1 1. How you can check about the onto? Draw the vertical line. If it cut only at the 1 point, then it is a 1 1. You can see I can draw the horizontal line. How many points of the intersection? 1. That's a unique point. So yes, it is a 1 1. Draw the vertical line. How many points of intersection of the cut? Again a 1 point. Yes, this is my on 2. Look at this one. If I draw the point, cut only 1 point, it's a 1 1. Yes. If you draw the vertical line, again it is my cut at only 1 point. Yes, this is also on 2. That means this is my bijective map. This is my bijective. There is a 1 to 1 and on 2 from A to B. Yes, this is my A. I can define a function from A to B. There is no 1 to 1. That's wrong, because there is a 1 1. There is no 1 to 1 map. Wrong. There is no on to. Wrong, because there is a on to functions are. Fine. You can see if I simply choose the function is my x square while x is in my R. Clearly say this is my not 1 1. Is it 1 1? No, because you know f of 1 is f of minus 1, but 1 and so if you draw the graph, now you can see about this concept. Draw the horizontal line. How many point of intersection? 2 points. So that means this is not 1 1. Fine. If you look about the x cube, either you can draw a horizontal line this, again cut 1 point. If you draw horizontal this, again 1 point. So that is a 1 1. Similarly for this case. So the right answer is A is my correct answer. F is a mapping from x to x such that, what does it mean? F circle F is identity. Fine. So that means this function will be my 1 1. This function will be my on 2. But we have the same function. So F is 1 1. F is on to both. F is 1 1. F is on to both. That means F is my bijective map. F is 1 1 but not on to. That's a wrong option. Wrong option. Wrong. You can see with the help of the very shortcut tricks you can solve this problem. Simple method. Always remember, you can see if you remember my last lecture on the linear algebra, you can remember the lecture on the rank of the matrix which I have explained in this way. If you remember, I can recall you. If my A is M cross N matrix, B is my n cross p matrix such that AB is equal to identity. Can you define the rank of the A, rank of the B directly? Yes, you can. You must watch about this lecture, rank of the matrix. What is the rank? A. A is my row, number of the row M. B is my column, number of the columns is P, and you can see that is the right answer. The same concept I have applied on the mapping. So you must watch. That's why I'm asking you. You can subscribe my YouTube channel so that you can get the notification when I uploaded my next video. I hope you can like and comment on this video as well. Okay, next one is S is the collection of all those pairs such that it's just like a circle. Fine, where n is my natural number, and either x belongs to the Q and y belongs to the Q. Q is the set of the rational numbers, n is my positive. Which of the following is finite, countable, uncountable, empty? Basically we're talking about the cardinality. Okay, either x belongs to, so we can think about the two cases. X belongs to the Q. If I prove that y is also my Q, that means if this is my Q and Q is my countable, then S is my countable. If I prove that X is in my Q, Y is in my R, and R is my uncountable, then S is my uncountable. Fine. Now, first of all, S is empty. I think that's wrong, because if you choose n is my 1, what will be my S is? Collection of all those pairs such that x square plus y square is my 1. So can you think about any of the x? Clearly say 1, 0. 1, 0 satisfied? Or you can say any of the element belongs to this. 1 is also belongs to the Q. So clearly say S is empty. Wrong. Fine. Now, firstly I can assume, okay, you must all know that if x belongs to the Q, then any of the constant minus x square also belongs to the Q. Fine, because 1 is my. Now can you find the value of the y from this case? Y is 1 over n square minus x square. Y is my plus minus 1 over n square minus x square. Now based on this concept, if x is in my Q, 1 over n is my natural number. Fine. So difference of the two, 1 over n square, is in my Q. Fine. So this minus x square is also the part of the Q. Under root of 1 minus x square is also the part of Q. That means y is the part of Q. Therefore x comma y, x is in Q, y is in Q. That means this S is in my Q. Q is my countable. Therefore S is my countable. Similarly, if you assume y is in my Q, fine, then can you find the value of the x? It's a plus minus 1 over n square minus y square. Again, by using the same concept, x is also in my Q, and Q is again my countable. So that means S is my countable. So B option is the correct option. So C, X is finite, non-empty set. It's a countable. It's not a finite. Okay, look at this one. Given a 3 real constants A, B, C, D. Any real constant, I can choose A is 1, B is 0, C 0, D 0. Any real constants. Fine. Your equation will be 2xy plus y square, which is x square. Fine. Now clearly say this number is my positive, always positive. That means this part is always positive. Fine. Also you can think about like a linear algebra. This is my quadratic form. Fine. Forget about this ABCD. You can see this is my square, which is always positive. This is square, always positive. Right hand side is my always positive. That means lambda x square plus 2xy plus y square is always greater than 0. That means the quadratic form is positive. So can you define the matrix corresponding to this? Coefficient of x square, coefficient of y square, half the coefficient of xy, half the coefficient of xy. Now when it's said to be greater than 0 means positive definite. When it's said to be the positive definite, when the principal minors are my greater than equal to 0. So what is the first principal minor? Lambda greater than 0. Second principal minor, lambda minus 1 greater than 0. So lambda is negative by the cancel out. There is no such lambda, cancel out. Lambda is lies between 0 and 1, wrong, because lambda is greater than 0. I can choose lambda is 3, which is, and clearly say from this case lambda is my greater than 1 is the right answer of this problem. So that question is basically the part of the real analysis of linear algebra. X denotes the 2-point set is 0, 1. Write xj as, this is my xj, y is my x1 is a infinite product. Product of j is 1, xj. Which of the following set is my true? Which of the following is true? Countable, cardinality, uncountable. Once you are talking about the countable, we need to find the cardinality. Now clearly say what is the x? Is a 0, 1, which is the mapping of the countable set. Fine. Now what is the meaning of this? Is the infinite. It is my uncountable. Fine. So y is my uncountable. This is it's a finite. It's an infinite product of this. Otherwise you can see what is the cardinality of the xj? 2. What is the cardinality of this? 2 raised to power. It's just like say power set. Fine. So it's a 2 raised to power. It's a 2 into 2 into 2 into 2. Fine. Fine. This is my uncountable. So y is my uncountable. Now cardinality of y. Okay, look at this one. What is this option? Is u union is n j is equal to 1 x j is countable or not. Now you can see this number is a, what is the cardinality of this part? What is the cardinality of this part? Is 2 into 2 into 2, how many times? N times. That's a 2 raised to power n, which is finite. Every finite, if I consider the set of this, every finite set is my countable. And what is this meaning of this? That is a countable union of the, what is this case is countable set. What is the countable union of the countable set? Is my countable. So yes, this is my uncountable, is the wrong option. Cardinality of y. Y is my uncountable. What is the cardinality of the uncountable set? C. What is the cardinality of the, what is the 0, 1? It is my uncountable set. Fine. So what is the cardinality of 0, 1? Again it's a C. Yes, both are the correct options. So B and D are my right answer. For each j varies from 1, 2, 3 and so on, let Aj be the finite set containing at least the 2 distinct elements. So let's say A and B. Fine. Countable, uncountable. So again we will work on the cardinality. Cardinality of Aj is my 2 for each j. Fine. Then union j varies from 1 Aj. That means A1 union A2 union A3 and so on. First of all, what is the mark of this? Aj is my countable because it's a finite set. Fine. Every finite set is my countable. So Aj is countable for each j. Clear? Now, once you know countable, so what is that? It's a countable. It's a countable union of countable set. we know the countable union of the countable set is countable set. The first one is countable set, correct option. Look at this one again. It is union n varies from 1 to infinity, n j is equal to 1 of aj. Now clearly say aj is my finite set. Finite product of the finite set is finite, or you can see the cardinality of this is 2 raised to power n. Fine. Once is a 2 raised to power n. No, you can say it's a power set. Basically it's a power set. No, cardinality is not 2. Is at least 2 distinct animal. Cardinality is greater than equal to 2. So cardinality is but that's a finite set. Fine. If it's a finite set, it's a countable. That's fine. Okay, we will see. Okay, so that means this aj, which is basically a power set. Fine. So what is the cardinality of the power set is? What is the cardinality of the power set? 2 raised to power cardinality of aj. So what is the cardinality of the aj? Is at finite. So what is the cardinality of the finite set is? Fine. Whatever the cardinality of the finite set, I called as this number, which is my c, and c is my uncountable. So once this is my uncountable, union of them is also my, but no, is uncountable. Yes, it's uncountable, and the finite union is the wrong option. Product of j varies from 1 to infinity is aj is uncountable. How you can prove that it's uncountable is, but it's a countable. Fine. And the aj is my uncountable. Can you think about that? Okay, we can prove the cardinality. I can found the cardinality of this case. Fine. The cardinality of a has a finite set. Cardinality is my alpha naught into alpha naught. How many times is? Infinite times. That is my c, and c is my uncountable. So yes, it's my uncountable is the correct option. Union of aj is uncountable. Union of aj is uncountable. Aj is my finite set. Countable union of the countable set is countable, but he said uncountable. So this option is cancelled. A and C are my right answer of this problem. You can see there is a difference between this example and the previous one. In the previous one, the cardinality is fixed as a 2. Fine. And then that's why this element has a 2 raised to power n is a finite set. But in this case, the cardinality is greater than equal to 2. Fine. So that means this element is what is that? This is the power set. Once is a power set, so it has a uncountable. So that's why this option is cancelled out. There is a difference between these two cases. Okay, let A is the any set, P of A is the power set, such that P of A is collection of all those subset which is satisfied this property. Okay, P of A is equal to empty. First option is cancelled. Why? Because what is the meaning of the power set? Power set must consist of the phi element at least, phi and itself the set X. So power set is empty set is the wrong option. P of A is a finite set for some A. A is any set. P of A is the power set. So for some, it is not for all. So let A is my 1, 2. What is the cardinality of A? 2. Can you define the cardinality of power set of A? 2 raised to power 2, 4, which is finite. So it's a finite set for some A. Yes, for the sum A. If it is set for all A, then it's a wrong option, because we can define the any of the, say A is my Z. Fine. Then it's a infinite set. So cardinality of the power set is 2 raised to power, this is my C. P of A is countable set for sum A. P of A is countable set for sum A. Again the same example, 1, 2. So what is that? A is my finite set. Every finite set is my countable set. So once it's countable, P of A is also my countable. Why? Because P of A is also my finite set. You can see what is the power set of this, either 5, 1, 2, fine, or complete A. So what is the cardinality of this? Cardinality of this is 4, which is finite. Every finite set is my countable. So yes, it's my countable. P of A is uncountable. Yes, you can see if I choose A is my N or Z or Q, fine, then what is the my P of A? 2 raised to power, cardinality of P of A is the 2 raised to power alpha naught C, which is uncountable. Yes, for the sum is the right answer. So B, C and D are my right answer of this problem. A is the closed subset of the R such that A is not phi, A is not complete set R. Then which of the following is my true? Can you take any example of the closed subset? Say A comma B. It's a countable, yes. It's a compact, yes. It's not open. Which of the following statement is correct? Okay, I need to discard the option. So based on this, we can never discard them. If I choose this number, fine, clearly say this is not compact, this is not countable, fine, okay, fine. Moreover, we all know in the real line, R is my real line, fine. If R is my real line, the set which is open and close both, you know which set which is open and close both, which set which is open and close both in the real line is either the empty set or the itself R, but it is given that A is neither the phi nor the R. That means A is in between them. Any set apart from the phi and A, that means A is not open, fine. So that means A is not open is the correct option. Closer of them is the interior, that's again the wrong option. A is not open is the right answer. F is my monotonic function. Then they are talking about the discontinuity, countable, uncountable, discontinuity. Monotonic, whether it's an increasing function or it's a decreasing function, anything. Always remember that every monotonic function, you know what kind of the discontinuities they have. Every monotonic functions have what kind of the discontinuities? The monotonic functions, every monotonic functions have only, yes, it's a jump discontinuity only, fine. Every monotonic function has only jump discontinuity of the first kind. So it has no discontinuity, cancel. And once it has a jump discontinuity, what is the jump discontinuity? And the cardinality of the how many jump discontinuities are there? They are always with the countably many discontinuities of this kind. This kind of discontinuity is, this means that the jump kind of the discontinuity is always countably many. So that means it has finitely many, wrong, because it's a countably finite. So it has at most countable, yes, uncountable, wrong. So the right option is C is the correct answer. The number of the onto map from A to B such that cardinality of A is 4, cardinality of B is my 3. That's simple. I earlier suggested is the formula R varies from 1 to cardinality of B minus 1 and R raised to power cardinality of where this is called as a M, this is called as a N into NCM. This is CR. Now you can substitute, this is the first method, fine. So I can substitute this value. M is my 3 minus R is the summation part, N is my 4, M is my 3 of R. Now you can substitute 1, 2, 3. If you substitute 1, it's my plus 1. If you substitute R is 1, it's a plus 1. 3C1 is a 3 plus. When you substitute 2, it is my minus 1. When you substitute 2, it's a 16. 3C2 is again my 3. When you substitute 3, it's my 1. It's a 3 raised to power 4. 3C1 is my 1. So that is my 3 minus 48 is 9, 81. 9 and 9, 81. That is 84 minus 48. That is 36. A is my right answer. Fine. Otherwise, you can remember that if I called cardinality of A is my M, cardinality of B is my M, then you can define the cardinality on two functions. If you not remember this formula, then you can define the cardinality is M raised to power N minus cardinality of M C1 M minus 1 plus minus plus minus plus minus M minus 2 plus MC3 M minus 3 plus minus plus minus plus and so on. Fine. Now you can see what is the M? M is my 3, N is my 4. So M minus 3, it will be 0. 3 raised to power 4. 3C1 is 3. So you can see 3. M minus 1, 3 minus 1, 2 raised to power 4. M is my 3. 3C2 is again 3. 3 minus 1 is 1 plus 0. So again you can see it is my 81, 48 plus 3, which is the same as answer A. Y is the set, cardinality of Y is my 100, H is the mapping which is strictly increasing, then the total number of the functions from Y to Y satisfying this. Okay, just firstly think about that this condition is not satisfied. Fine. Then how many function maps? That means the cardinality of Y raised to power cardinality of Y. Fine. Now in this case this condition is given to you, but one more condition is given. H is my increasing function, strictly increasing function, is a Y to Y. Can you think about any function which is a strictly increasing function? You can see H is Y is my positive number. Fine. So I can simply say is always increasing function. Now we will see whether this map will satisfy this condition or not. If it is not satisfied, we can think about the other example. That means I can simply think about identity. Fine. This is means H is my identity. So if H is identity, then this portion left hand side is my G of J, and since H is my identity, so this mapping is G of J, which satisfied. So that means I can take on H is my identity map. Fine. It is any increasing function, so identity map I can choose on them. So what is the right answer of this? That means cardinality of Y is 100 raised to power 100. So C is my right answer of this problem. For any set X, whether it's a finite or infinite, P of X is the set of all those power subset, omega X is the set of all those functions of this. If X is finite, you can choose any finite set, let's say 1, 2. Fine. Then it's a finite set. It means they are not talking about the countability, but if it is finite set, you can say this is the countable also. What is the power set of X? It consists of cardinality of X is my 2. What is the cardinality of the power set? 4, which is also finite. So that means this option is correct option. If in the coming examination, if somebody said if X is finite, then P of X is countable, you can see every finite set is countable. If x and y are my finite set, you can choose again anyone, say 5, or easiest one you can choose as a x is 1, y is my 2. These are my finite set. And if there is a 1-1 correspondence between power set of x to power set of y, there is a 1-1. What does it means? When it will the 1 to 1, that means cardinality of this must be less than equal to the cardinality of y. Fine. So if I choose an x and y here, what is the cardinality of the x power set? What is the cardinality of the power set is 2. Cardinality of the power set y is also 2. That means this property is satisfied. Then there is a 1-1 correspondence between the x and y. That means your target is to prove this number. There is a 1-1 correspondence between this one. So that means your target is to prove f is a mapping from x to y is 1-1. So I think very simple. How you can prove that? In general, if you say cardinality of x is n, cardinality of y is m, then cardinality of the p of x is 2 raised to power n is less than of the 2 raised to power m. Clearly say n is less than equal to m. What does it means? That means f is 1-1. So yes, this option is correct option. Look at the third option. X, there is no correspondence, 1-1 correspondence between x and px. There is no correspondence between x and px. It means there are two choices. One is from x to px and second is from px to x. Because in the statement it is not given to you that whether you define the map from x to px or px to x. So let's see both the cases. There is no. When, if I look at that, if I prove that this, if this is true, then cardinality of A is less than cardinality of B. Fine. If I prove that this is not less than of B, then it is not 1. Fine. And this is our target. What is the cardinality of x? What is the x? X is the any set. I can choose x is again 1, 2. Cardinality of this set is 2. Cardinality of this set is 4, which is possible, but we can never say that this existence, because converse is not true. Look at this one. If I choose x is the any set, cardinality of this is 4, cardinality of this is 2, which is not satisfied. That means there is no 1-to-1 correspondence between the power set x to the x. Yes, this option is also correct option. There is a 1-to-1 correspondence between the gamma of x. What is the gamma x is? This. Okay, again, if I choose x is my 1, 2, because x is any set, I assume x is my finite set, or you can choose as an infinite set. There is no issue. We will consider both cases. Fine. If x is my infinite set, say n, fine. Then what is the power set is? Cardinality of the power set is 2 raised to power xi naught is c. So this is my c. First case is infinite. Xi of x. What is the cardinality of this? What is the cardinality of this is 2 raised to power cardinality of x. If I consider x is n, you can see both are my same. Fine. But if you consider as a finite set, then what is the power set? Cardinality of the power set is 4 corresponding to this. What is the omega of x? 2 raised to power cardinality of x. Again it's a 4. Yes, there is a 1-to-1 correspondence between them. Moreover, this is my bijective map. So once it is a bijective, it means there is a 1-1 as well. Okay, which of the following statement are my true? There exist 3 mutually disjoint subset of the R. Fine. For each n, there exist n mutually disjoint subset of the R. Dense, countable, many subset, disjoint, disjoint. Or in all case, we need a disjoint subset. So firstly, I can consider as a 3 disjoint subset. Can you think about any of the disjoint subset? q complement, fine, and it will be q plus any number, say alpha, where alpha belongs to the, fine, because you can see what is the A intersection B, 5. So whatever I can choose, there is no need of this case. Whatever the value of C I can choose, and this is always 5, fine. Also, what is the A complement? R. What is the B complement? Again R. If I choose the C in such a way that it will be my R, can you think about the C also? So definitely if I choose the C in such a manner that q plus alpha, fine, where alpha is the part of the q complement, such that alpha is the part of q, fine. So again you can see what is the meaning of this. It is my dense. Anyhow, we don't need to prove the dense, because in each option dense is already given to you, fine. Now you can see this is my disjoint. There exists 3, fine. There exists n. Definitely if I consider the one more set, whatever the set is there, fine, the intersection of A intersection B, C intersection D is also 5. So yes, there exists n mutually disjoint set, fine. There exists countably infinitely many disjoint. Yes, you can define how much. There are uncountable many disjoint sets, fine. All are my right answer of this problem. Now you can see it's a recent year paper. AN is a collection of the two non-empty subset of the Z such that intersection is phi for M is not equal to N. I can simply choose the two cases, A1, A2, fine. M is not equal to N satisfied. I can choose an two set collection of the two subset of the Z such that intersection is phi. Very simple. I can choose this is my A2, this is my A1, fine. That means I can choose an as a set is minus infinity to plus 1, because it's a Z, it's a minus 1, and this case 0, 1 up to infinity. Clearly say the intersection is my phi, fine, and Z is my union. So clearly say A1 union A2 is my complete Z. So it's satisfied. AN is finite for N, because I have chosen the only two case. So whether it's a finite, this is my infinite. A2 is also infinite. So A is a finite cross. AN is finite for some integer. You can see in both the cases which satisfy the properties is not a finite. AN is infinite for some, that's true. But can you think about any other example? That's true. Again, infinite. Can you think about all these? I can choose an AN is singleton set, like A1 is 1, A2 is 2, and so on. So clearly say A1 intersection A2 intersection A3 is my phi, and union of AI is my Z, fine. I can choose an A1, 2, 3, and similarly for the negative case and so on. Again, which satisfy these properties, you can see A is finite, A is infinite, but none of the set is my infinite. So therefore this option is also cancelled. Only right option is D is my correct answer. D is my countable, either a finite, you can see the finite, or this is my infinite. So the right answer is D is my correct answer of this problem. I hope you can like and comment on this video. I will upload my next video based on your good response. Consider the following set of the functions w, x, y, z, which of the following has the same cardinality. W, what is that? W is set of the constant function on the R such that f of x is constant, say 1. X again is from the R to R such that it's a polynomial function. So f of x is any polynomial, say a plus bx. F y is the collection of continuous function on the R such that it's a continuous function. So f of x is my continuous and z is my collection of all those function on the R. So it can be continuous. So definitely you can see y is the subset of the x because it's a all function. So I can choose it as a one continuous. Every polynomial function is a continuous function and every constant is also the polynomial. Fine. So what does it mean? Because we are talking about the cardinality. Cardinality of y is less than of the cardinality of x of this case. Fine. Now can you define the cardinality of this? That is the number of the functions. You can see it's a R to R. All are my R to R. That means all have the same cardinality. Fine, because in this case also you can see A and B belongs to the R. So all have my same cardinality. So the right answer is, last option is the right answer. An infinite binary string A is A1, A2 where each of the AN is my 0, 1. Fix a string S which is defined as S1, S2 up to the S is infinite, Sn and so on, where Sn is my 1 if and only if n is my prime. Fine. Let S is the collection of all those pairs. There exists M, An is equal to Sn. That means we have to define A1 is a string. Firstly, I can simplify this case. Firstly, I can fix, because we have to fix the string and the string is dependent on the n. I can fix the value of the prime. Say n is 3, which is a prime. Fine. Then what will be your S? S is my A, A1, A2, A3 such that A3 is equal to S3. So that means A1, A2, S3. Fine. Now, this is my fine. Now what is the value of the S3? S3 is my 1. So it will be my A1, A2, 1. What is the value of the A1, A2? A1 and A2 is either 0, 1, either 0, 1. Then the cardinality of this set S. I think that's over. Can you find the cardinality of this set? How many cardinality of this set is there? So it's a 2 raised to power. You have the 4 choices. One choice is my fix. So it will be 2 raised to power 2 is my cardinality of this S. That will be my finite. So once this will be my finite, so definitely 1 is not the right answer. Finite but more than 1. But now the question is whether it's a finite or countable. Now is for the fixed n. So in general we can say it's 2 raised to power. If I choose 3, then it will be the 2. So it will be 2 raised to power n minus 1. Fine. So what does it mean? That is the countable union of the finite set, because 2 raised to power n I can correlate with the power set of n, that is x1, x2, and the last number is my 1. This is my 2 raised to power n minus 1. So countable union of the finite set is countable. Fine. So it's uncountable, cancel out. But the set is my infinite, countable infinite, finite is the wrong answer. C is my correct answer of this problem. We will see the next lecture on the sequence of the real numbers. Till then, you can share, like and comment on my video. Best of luck students. Happy learning.